Even though the James Webb Space Telescope has only been in use for a little over 2 years, it has advanced significantly. The telescope's entire potential has just been unveiled by researchers, and you'll be astounded to learn exactly how potent humanity's most recent creation is. Furthermore, it may have recently discovered life on another planet. How strong is the James Webb Telescope, and has it discovered life at last on a far-off exoplanet? Prepare to learn all of this and more. The James Webb Space Telescope was launched in 2021 and has since been observing the far reaches of the cosmos for signs of life and potentially advanced alien civilizations. It has also been examining the atmospheres of nearby exoplanets to look for gases produced by biological life or biosignatures and chemicals that may be produced by these alien civilizations. However, scientists were unsure if the telescope could actually accomplish these significant technological achievements. Consequently, they decided to test the James Webb Space Telescope's ability to identify intelligent life from Earth, the only planet known to be both livable and inhabited. In a recent study, scientists collected a spectrum of Earth's atmosphere and purposefully distorted the data to give the impression that the telescope was observing Earth's atmosphere from a great distance away. Using a computer model that rearranged JWST's sensor capabilities, they examined whether the spacecraft might identify important technosignatures like nitrogen dioxide and chlorofluorocarbons, as well as biosignatures like oxygen and methane, which are produced by biological life on Earth. The research team discovered that the modified dataset would be comparable to the James Webb Space Telescope looking down at Earth from the TRAPPIST-1 star system, which is located approximately 40 light-years away. The results were unexpected. Nevertheless, the telescope should be able to find evidence of extraterrestrial life within 40 light-years of Earth and may even be able to find evidence of such life up to 50 light-years away. However, a recent and fascinating finding may simply demonstrate that if life existed everywhere across the Milky Way, a telescope could detect it. The K2-18b planet, which was discovered recently, is about 120 light-years from Earth. The exoplanet is around 2 to 3 times larger than Earth and has an 8.6 times mass of Earth. Since it is a high-shine world, there is most likely a liquid water ocean on its surface and a significant concentration of hydrogen in its atmosphere. The JWST discovered carbon dioxide and methane while examining the atmosphere of K2-18b. This is an exciting discovery in and of itself, but it's not what made the discovery particularly intriguing. Dimethyl sulfide, DMS, a chemical that is present on Earth, might possibly exist on this extraterrestrial planet. Since DMS is only formed as a byproduct of life on our planet, it is especially interesting. It is often produced on Earth in maritime conditions by phytoplankton, a microscopic organism that resembles plants. Because of this, DMS may represent a biosignature, something that has never been found on an exoplanet. Astronomers used to focus mostly on rocky planets when looking for evidence of life. However, keen worlds, which are hot, water-covered, and have a hydrogen atmosphere, are thought to be more promising as prospects for extraterrestrial life. These planets are better suited for atmospheric investigations. This is also likely due to the fact that the vast majority of exoplanets that have been found differ greatly from Earth. It's not yet clear to scientists whether dimethyl sulfide is present in K2-18b. We need more information to validate these results because the JWST hasn't had much time to observe the exoplanet. We shall soon ascertain whether significant quantities of DMS are present on K2-18b. Even then, though, we cannot be positive that life exists on this heme planet. Biosignatures are challenging for a number of reasons. Our primary basis for studying them is our understanding of Earth's environment. An additional issue is that biosignatures are not limited to living things. They might originate from other sources as well. Consider oxygen, for example. Although it is created by plants and algae on our planet through photosynthesis, it can also come from pure geological or non-biological processes, such as the disintegration of oxygen-containing minerals or the outcome of chemical reactions involving substances rich in oxygen. We are undoubtedly moving forward. Initially, we concentrated on locating planets with sizes comparable to Earth. Next, we added the habitability zone to our list of requirements, which permits the presence of liquid water. we are currently going much further into researching the chemical makeup of exoplanets. We can already use a technique known as atmospheric spectroscopy to identify biosignatures on extraterrestrial worlds. Even at this advanced stage of technological development, researchers are finding novel approaches for identifying biomarkers on exoplanets. Some of these techniques may even be able to depict the appearance of extraterrestrial life forms. In one study, researchers examined the Archean era of Earth's history, which was home to a wide variety of early living forms, including purple bacteria, to determine if the appearance of Earth from a distance might change if such organisms were widely present. A number of simulations were developed, including variables such as the presence and density of clouds in the atmosphere at the time of observation, as well as the amount and distribution of bacteria in both aquatic and terrestrial habitats. The study's findings were exciting. Purple bacteria stand out in a particular range of colors due to their unique ability to reflect light. It is comparable to the red edge phenomenon, which is characterized by a sudden rise in near-infrared reflectance in green vegetation found in leafy plants. However, this rise occurs in a somewhat different color spectrum for purple bacteria. The bacteria's peculiar colors and capacity to absorb light are what give it its unusual quality. They are better able to absorb and use light to meet their energy needs. Since an exoplanet's skies don't get much cloud cover and its land sections are home to a lot of purple bacteria, we may be able to use particular optical filters to find evidence of these species. Undoubtedly, the James Webb Space Telescope has recently produced a number of fascinating new findings. However, these are not the only discoveries the telescope has produced this year. The next one has sparked a great deal of debate and discussion. All matter is drawn together by the attractive force of gravity, and our universe is expanding. Physicists used to think that this expansion should eventually slow down. However, we've also found that the expansion of the cosmos is speeding up. If we took ordinary substance alone into account, nothing made sense. Therefore, there has to be another factor involved. At that time, scientists began to speculate about the existence of dark matter and dark energy, the two enigmatic substances that predominate in the universe. Dark matter, similar to an imperceptible material in space, keeps galaxies and clusters of galaxies together. It makes up 27% of the cosmos overall and functions as a kind of subterranean structure that keeps everything together. It doesn't emit light and doesn't interact with regular matter, but its gravitational fingerprints allow for further study. An additional perplexing phenomenon is dark energy. It is responsible for the cosmos' accelerated expansion and comprises roughly 68% of the universe. We can determine its quantity by looking at the patterns and motions of galaxies. Scientists have taken meticulous measurements of things like cosmic background radiation and the overall structure of the universe, which has allowed them to know its existence even if humans cannot see it or touch it. Astrophysicists lacked evidence for the presence of dark matter or dark energy until recently, but perhaps this has recently altered. Nuclear fusion is a mechanism that powers stars, including our sun, at their cores. The process of nuclear fusion is the combination of lighter elements, such as hydrogen, to produce heavier elements, mainly helium. The tremendous amount of energy released during this process is what gives stars their dazzling brightness. In the vastness of space, this energy is released as heat and light. However, dark matter, or more specifically the heat generated during self-annihilation, might offer an alternative source of energy for stars. The telescope may examine some of the universe's most remote regions with the JWST's Advanced Deep Extragalactic Survey, essentially peering into the past. Furthermore, because the early cosmos was very different from what it is today, incredibly strange celestial bodies, such as stars hundreds of times more massive than those forming today, formed back then. 4 stars designated Jades, GZ10, Jades, GSZ111, Jades, GSZ12, and Jades, GSZ13 were found. Jades, GSZ12 and Jades, GSZ13, 2 of the 4 freshly discovered stars, are some of the most distant celestial bodies ever sighted. True, they are stars, but not just any stars. Astrophysicists speculate that Jades, GSZ111, Jades, GSZ12, and Jades, JWST are hypothetical dark stars because they may be driven by dark matter. These stars are bright, perhaps 1 billion times brighter than the Sun and millions of times more massive. Despite being referred to as dark stars, according to scientific theories, dark stars formed in areas rich in dark matter that were created when helium and hydrogen clouds collapsed soon after the Big Bang. Supersymmetry is a theory in physics that may help to explain how such stars are created. Think of the early cosmos as a cosmic kitchen, the birthplace of dark stars. When clouds of hydrogen and helium, components of the Big Bang, combine, these stars begin to cook. Dark matter particles may now resemble cosmic twins with separate superpartners if they possess a unique property known as supersymmetry. Similar to matter-antimatter annihilation, these particles evaporate and release a blast of energy whenever they collide. Afterwards, other particles, including photons, electron-positron couples, and neutrinos, are formed as a result of this energy. While the other elements remain inside and interact, neutrinos leave the cloud since they hardly ever interact with anything. They impart their energy to the helium and hydrogen in the cloud as they smash against it. As a result of this energy transfer, the cloud warms up and black stars begin to form. Furthermore, because these stars don't release high-energy light like stars driven by nuclear fusion do, they can stay cold for a lot longer and expand in size. Dark stars may eventually cool to the same surface temperature as the Sun, but they will be billions of times brighter. These stars would have a radius of up to 10 astronomical units, no core, and a brightness comparable to that of an entire galaxy of regular stars. These newborn galaxies, known as mini-halos, appeared 200 million years after the Big Bang and had a distinct composition, primarily composed of dark matter. Only in the early cosmos, when there were only light elements like hydrogen and helium and no heavy elements, could these unique circumstances have existed. Thus, dark stars could only develop at the beginning of cosmic history in these mini-halos. This could be the cause of our previous inability to witness any. The advancement of technology was insufficient to enable us to look that far back in time. However, with the advent of the JWST, things have begun to drastically shift. So how did these things get picked up by the JWST? Gravitational lensing is the phenomenon where light is bent along its course by the gravitational field of a giant galaxy passing in front of a far-off star or galaxy. The light from the far-off objects is magnified and distorted by this effect while the actual physical distance to those objects remains unchanged. This makes it possible for telescopes to view far-off astronomical objects brighter, giving the impression that they have been enlarged or moved closer to our line of sight. However, it would take a lot longer to identify these objects as a new class of stars fueled by dark matter due to the unfathomable distances involved. JWST and JWST were once believed to be galaxies. However, 3 of the 4 celestial bodies that have been found may be hypothetical black stars based on computer calculations. If verified, their findings would be groundbreaking and offer solutions to 3 significant cosmic riddles. The James Webb Space Telescope has previously discovered an incredibly high number of far-off galaxies that seem excessively enormous for their early universe age. This is in opposition to the conventional cosmological paradigm, which states that smaller galaxies emerge initially before eventually expanding. Therefore, if some of those galaxies turn out to be dark stars, the energy from dark matter interactions would cause them to develop quickly, enabling them to reach supermassive sizes early on. This could contribute to the explanation of why the early cosmos contains so many massive galaxies. The early universe's supermassive black holes, which are too huge to have been formed from regular stars at such an early stage in cosmic history, could potentially be explained by large dark stars that later crashed. And then there's dark matter's nature. Dark stars would provide evidence for the existence of dark matter particles and demonstrate how these particles might interact with one another outside of gravity. The JWST was also able to identify 2 other fascinating stars, Mothra and Godzilla, due to gravitational lensing. Both stars are far brighter than anticipated and are more than 10 billion light-years away from Earth. Kaiju stars are very rare stars with this level of brightness. The star system Mothra is a binary supergiant, with one star at approximately 5,000 Kelvin in temperature and brightness, and the other at 125,000 times the Sun's brightness and 14,000 Kelvin in temperature. Furthermore, Godzilla is regarded as the universe's brightest star ever found. The issue is that the brightness of the stars is far higher than what can be explained by the Earth's distance from a galaxy cluster, which acts as a magnifier. There is something else there that is far closer to the stars, according to scientists. This object, whatever it is, weighs between 10,000 and 2,500,000 times that of the Sun. Furthermore, it cannot be a different star or a group of stars as detected by the JWST. The telescope cannot see the structure or item that is adding magnification. Thus, it may be a black hole or a region with a high concentration of dark matter, such as a dwarf galaxy which is virtually entirely composed of it. This would be further indication that dark matter exists. Though there is still more work to be done to solve these cosmological puzzles, we have discovered a lot of exciting things recently, and it appears that the universe will only get more fascinating from now on. That's all the time we have left. But before we go, we'd like to hear from you, our viewers. Do you think the James Webb Space Telescope will eventually find evidence of an extraterrestrial civilization? And if so, how would that affect human existence on Earth? Post your ideas in the comments section below. We really hope you liked the video. Thank you for viewing, and stay tuned for more amazing discoveries about the universe and our world.